Hello friends, I am Mr. Sanjay K. Bhadke, presently working as an assistant professor at Department of Civil Engineering, Tulsiramji Gaikwad-Patil College of Engineering and Technology, Nagpur. Friends, in last class we discussed about the basic concept of design of roads. We also discussed about the various traffic roads, classification of roads, and we also discussed about the what is highway and what is bridges. Friends, in today's class, we are going to discuss about the geometric design which is required before the constructions of the road. So, today's our topic is geometric design, which include the various survey which were carried out for the construction of the road or constructions of the bridges. This syllabus is divided in various parts and various definitions. So in this topic we are going to discuss and we are going to study about the camber. What do you mean by camber? What are the various classifications of the camber? How cambers are useful? What are the various elevations? What are the various slopes which are useful for the camber? So all these things we are going to discuss in today's class. We are also going to discuss about the side distance. What do you mean by side distance? What side distance are important in the road construction? How we can minimize the accident by know the study regarding through the side distance. We are also going to discuss about the various types of curves. What do you mean by transition curve? What do you mean by vertical curve? How curves are important for the road construction. Secondly, we are going to discuss about the super elevation. What is the definition of super elevation? What are the various importance of super elevation? What do you mean by the extra widening? How extra widening is useful for the road construction? What do you mean by summit curve? What do you mean by valley curves? And how curves and their necessity and how they are important for the road construction? So all these things we are going to discuss in today's class. The specific objectives of this topic or course outcomes are the student will able to understand the various terminology which is related with the construction of the highway and the roadways. Basically, the student will able to understand the design the highway cross sections such as super elevation, transition curve, summit curve, valleys curve, and what are the various applications of this curve for the various road structures. So uh, it is very important before going to construction of the road that we should know the geometric design of the area, and we should know what are the various type of survey should be carried out for the construction of the road. The geometric design include various types of site. What is the topography of the area, how this area is classified, the availability of material, the availability of labors in particular area. So all these things we are going to discuss in the geometric design. Then what do you mean by the geometry and what are the various factor which affect on the geometric design? The geometric design of the highway is deal with the dimension and layout of the visible features of the highway. The emphasis of the geometric design is to address the requirement of the driver and the vehicle such as safety, comfort and efficiency. We know that when we are driving any vehicle on the road or due to the geometric design of the road, there should not be any harm to the vehicles. So if our geometric design is proper, so it will provide a more safety to the drivers and other road users. So safety and comfort is the very important part of the geometric design. These features normally consider are the cross sections element, side distance consideration, horizontal curvature, gradient and intersections. So if you want to reduce the various road accidents, so in that case the curvature those we are providing, gradients and intersection those are we are providing, that should be proper. The design of this feature is to be great extent influenced by the driver behavior and psychology. We know that we can reduce the many accident by studying the psychology and behavior of the driver. It also includes the vehicle characteristics, traffic characteristics such as speed and volume. The proper geometric design will help in the reduction of the accident and their servicity. Therefore, the objective of geometric design is to provide the optimum efficiency in the traffic operation and maximum safety as responsible cost. The planning cannot be done stage wise in this case like that of the pavement, but has to be done well in advance. So you can understand one thing from this geometric design. So why this geometric design is important? So this geometric design is always important to reduce the various types of accident. So if your geometric design is proper, we are providing the proper type of gradients, proper type of intersections, proper type of horizontal curve. So we can obviously we can reduce the various accident. And one thing is very important, that reducing of the accident is also influenced by the driver behavior and its psychology. Now we are going to discuss about what are the various factors which affecting the geometric design. So you can say that highway alignment. Highway alignment. If highway alignment is straight, in that case there is a minimum chances of accident. So highway alignment and road classification is the important part of geometric design. Then pavement surface characteristics, cross section element which include the cross slope, various width of the roads and features in the road margin, side distance elements including the cross slope, various width and feature in the road margin, horizontal alignment which include the features like super elevation, transition curve, extra widening and setback distance. Then vehicle alignment and its component like gradient, side distance and design of length of the car, and intersection features like layout and capacity. So these are the various factors which are very important for the geometric design, which include the pavement surface, which include the highway alignment, what type of cross slope we are providing, what is the width of the road, what are the intersection we are providing, which type of curves we are using, whether it is a transition curve, extra widening those we are using, then how horizontal alignment we are providing, what type of gradient is there, and how side distance can be measured. So all these things are very important and this factor are affecting the geometric design. If we are using all these factor in proper manner, so we will get the proper geometric design, and this way we can reduce the various types of accident. The next point is the design speed. The design speed is also plays a very important role while we are doing the road construction. The what do you mean by the design speed? So design speed is the single most important factor that affect the geometric design. It is directly affect the side distance, horizontal curve and length of the vertical curve. Since the speed of the vehicles vary with the driver, trainer, etc. A design speed is adopted for all the geometric design. So basically in simple language, if I want to tell you what do you mean by the design speed. So design speed is the that speed, by using that speed the driver can properly drive his vehicle on the road and there should not be any chances of accident. So design speed plays a very important role for the road construction. Design speed is defined as the highest continuous speed at which the individual vehicle can travel with the safety on the highway when weather conditions are conducive. Design speed is different from the legal speed limit, which is the speed limit imposed to curb a common tendency of driver to travel behind an accepted safe speed. Design speed is also different from desirable speed, which is the maximum speed at which the driver would travel when unconcerned by the either traffic or local geometry. So it is very important when you are going to construct any road, that road should be designed properly. It should be designed for the required design speed, so that there should not be any type of accident, or we can minimize the accident. Next important thing is camber. So what do you mean by the camber? Basically, we know that in case of the rainy season, if continuous rain is there, so that rain, it will come on the road, and if the still water is there, there is no any drainage facility. So in that case, that water will provide the damage to the various material those who are using for the road construction. So for that purpose, we have to provide the camber or cant on the middle of the road. So what do you mean by the camber? The camber or cant is the cross slope which were provided to raise the middle of the road surface in the transfer direction to drain off rainwater from the road surface. So I thought you can understand. If you see the road minutely, we can see the middle portion of the road having the some raised direction. That particular raised cross slope is called as the camber, and we are providing that camber for the drainage of the rainwater, so that there should not be any type of harm to the road surface or road material. Then what are the various objectives, and why we are providing the camber? The objectives are as follows. The surface protection, especially for the gravel and bitumen road, it provides the surface protection. Subgrade protection by the proper drainage. Quick drying of the pavement, which turn increase in the safety. Basically, if continuous water on the road, so it is very harmful. There will be the skidding and slipping of the various vehicles. So to avoid all this thing, when we are providing the various design for the road, so in that case we have the provision to provide the camber, a cross slope at the middle surface of the road. So these cambers are available in various uh, slope, and we are providing this camber as per the recommendation given by the IRC, that is Indian Road Congress. It's having various type of slope like 1 is to 10, 1 is to 50, and as per the requirement of topography and as per the requirement of this site, we are changing the size and slope of the camber, and we are providing that. So I thought you can understand the concept of the camber. Then one of the important thing is the various types of side distance. To avoid the various types of accident on the road, the side distance plays a very important role. There are different types of side distance. Those we are going to study. Then what do you mean by the side distance? The side distance available from a point is the actual distance along the road surface over which a driver from a specified height above the carriageway has visibility or stationary or moving object. The three side distance situation are considered for a design. So in simple language, I want to tell you what do you mean by the side distance. The side distance is a particular type of distance through which one driver can see the next driver, and there should not be any type of collision or any type of contact between two vehicles. So there are various types of side distance. So what are these various type? So first is stopping side distance, or it is also called as the absolute minimum side distance. In short form, it is called as SSD. Second one is the intermediate side distance, ISD, or it is defined as the twice of the SSD. Then overtaking side distance, OSD, it is also called as the safe overtaking operation. The headlight side distance is the distance visible to a driver during night driving under the illumination of the headlight, and safe side distance to enter into the intersection. So you can understand one thing. Why these side distance are important? To avoid the various types of accident, there should not be any type of collision between two vehicles. So for this we should use and we should follow the rules and regulation which come under these various types of side distance. So while designing any road, we should consider all this type of side distance, and it is play a very important role for reducing the various types of accident or collision. So now we are going to discuss about the what do you mean by the stopping sight distance. So stopping sight distance SSD is the minimum sight distance available on a highway at any spot having the sufficient lane to enable the driver to stop a vehicle traveling at a desired speed safely without collision with any other obstruction. The stopping sight distance is also called as the safe stopping distance, and it is one of the important measure in the traffic engineering. We know that when we are traveling on the road, so it is a government or RT office rule that there should be the 4 to 5 feet distance between two vehicles, so that there should not be any collision if in case of emergency, if any driver applied the brake. So if we provide, or as per the our psychology, if we put 4 to 5 feet distance between two vehicles, so we can avoid the collision, and this is called as the stopping side distance, and we are providing this stopping side distance as a safety purpose. There should not be any collision, so we should remain with this side distance. There should be the 4 to 5 feet distance between two vehicles. So mathematically, this stopping side distance can be given by lag distance plus braking distance. So it is very important factor that lag distance is the distance the vehicle travel during the reaction time, and it is given whether it is velocity. Braking distance is the distance traveled by the vehicle during the braking operation. For a level road, this is obtained by equating the work done in stopping the vehicle and the kinetic energy of the vehicle. If the maximum frictional force developed and the braking distance is then work done against friction is stopping the vehicle is where the total weight of the vehicle. Then kinetic energy at the design speed, as earlier I told you, it will be given by lag distance plus a braking distance. So mathematically the stopping distance can be calculated by using this formula. So in this PowerPoint presentation you can see this is the formula. SSD is equal to Vt plus V square divided by 2G in the bracket F plus minus 001 into N. So this formula we can use for calculation of stopping side distance, and when we are going to see the numerical, in that case I will in detail told you how this formula can be used to calculate the stopping side distance. Now we are going to discuss about the overtaking side distance. The overtaking side distance is the minimum distance open to the vision of the driver of a vehicle intending to overtake the slow vehicle ahead safe against the traffic in the opposite direction. The overtaking side distance or passing side distance is measured along with the center line of the road over which a driver with his eye level 1.2 meter above the road surface can see the top of an object 1.2 meter above the road surface. So basically overtaking side distance, when there is a one vehicle is moving on the road and another vehicle is coming from back side or front side, so there should be the a distance of 1 meter to 1.2 meter between two vehicles on the same lane, so that there should not be any collision between the two vehicles while one is overtaking to another or another is overtaking to previous one. So it is very important that there should be the proper distance between two vehicles to avoid the any type of collision while one vehicle is overtaking to the another. So what are the various factors that affect on the OSD? The factors are velocity of the overtaking vehicles, overtaken vehicles and of vehicle coming in the opposite direction. Spacing between the vehicles which turn depend upon the speed, skill and reaction time of the driver, rate of acceleration and gradient of the road. So already previously I told that geometric design is very important part. So road characteristics, gradient of the road, and all these things are very important to avoid the accident. Same time the psychology of driver, how he is skilled, and what is his reaction time of the driver to applying the brakes, and rate of the acceleration. So all these things are very important. If everything is proper and we are providing the proper overtaking side distance, so in that case we are avoiding the various type of accident. So here you can see this is the mathematical formula. OSD is equal to VB V suffix B into T plus 2S plus V suffix B multiplied by under root of 4S divided by A plus V into T. So this is the mathematical formula through which we can calculate the overtaking side distance. And while we are taking the some numericals, in that time I will explain it briefly. Now we are going to discuss about the overtaking zones. So what do you mean by the overtaking zones? Basically, overtaking zones are provided when OSD cannot be provided. So you can, if you consider about the topographical area, if in that case, in some cases it is possible to provide the overtaking zone, but in some cases it is not possible to provide the overtaking zone on the highway. And all these things are depend upon the topographical area or what are the various site condition in that case. So when there is not possible to provide the OSD, in that case we are providing the OS zone, which is called as the overtaking zone. These are the zones which dedicated for the overtaking operation, marked with the wide road, and the desirable length of the overtaking zone is 5 times the OSD and minimum is 3 times the OSD. So in this figure you can see this is the design of one overtaking zone. So in this figure you can see that here OSD is provided and the distance has been shown 3 to 5 times of OSD, and they are also shown the S1 and S2 type of spacing, where S1 is called as the starting or overtaking zone beginning, and S2 is called as the ending or end of overtaking zone. So we are providing or we are providing or we are designing this type of overtaking zone to avoid the various types of accident. And I already told you that as per the requirement of proper topography, we are providing the overtaking zone, and we are providing the uh, overtaking zones specially as per the requirement. Basically, when there is a curve on the road, so in that case we should be careful to providing the OSD and OZ on the road. Next is very important point, that is the super elevation. So when there is a curve and any vehicle is moving on the curve, so in that case there is a starting of the super elevation force. So to avoid the any type of accident, we have to counterbalance this super elevation force, we have to counterbalance the centrifugal force. So super elevation plays a very important role in the road construction. So while we are going through the road construction, so in that case we should done the analysis of super elevation. A super elevation is also called as the cant or banking elevation, and it is the transverse slope provided at the horizontal curve to counteract this centrifugal force by providing the outer edge of the pavement with the respect to the inner edge throughout the length of the horizontal curve. When the outer edge is raised as compared to the inner edge, we will get the sufficient result, and we can counterbalance the effect of centrifugal force. In order to find out how much this rising should be, the following analysis may be done. The force acting on the vehicle while taking a horizontal curve with the super elevation. So you can see all this thing on the this vehicle. So this vehicle is moving on an inclined path, but while this moving on the inclined path, the weight of the vehicle is always acting in particular direction over the towards the earth surface. Same time, when vehicle is moving in forward direction, due to the inclination, we can convert this forward direction force into two components. That one component is p sine theta and second component is p cos theta. And we know that as per the laws of mathematical, we can balance the super elevation on the road. If counter force cannot be balanced, so in that case there is the chances of skidding or slipping of the various vehicles on the road. So this way super elevation and centrifugal force plays a very important role for the design. So when there is a we are providing the design, so in that case there should be the proper type of design of super elevation is required. The centrifugal force acting horizontally outward through the center of the gravity, and the weight of the vehicle acting downward through the center of the gravity. The frictional force between the wheel and the pavement along the surface inward. So here in case of super elevation, the center of gravity plays a very important role. So if everything is manageable, so in that case we can reduce the effect of the centrifugal force, and it is also helpful to avoid the various types of accident. Student, the next topic is the extra widening. So basically why we are providing the extra widening? So to avoid the any type of accident, we are providing the extra widening. So what do you mean by the extra widening? The extra widening, in that case, the we are providing the maximum or over surface, the outer surface of the road having the extra layer as compared to the inner surface to avoid the accident. That process is called as the extra widening. The extra widening refer to the additional width of the carriageway that is required on the curved section of the road over above and required on the straight alignment. This widening is done due to the two reasons. The first, the most important, is the additional width required for the vehicles taking a horizontal curve, and second is due to the tendency of the driver to play away from the edge of the carriageway as driver on the curve. The first is referred to the mechanical widening and the second is called as the psychological widening. Simply we can say what do you mean by extra widening. So when a vehicle is moving on the curve path, so outer edge having the maximum layer of the bitumens as compared to the inner edge, so that the driver can safely draw his vehicles from the curve. So that is called as the extra widening, providing maximum layer of the bitumen in outer side of the road or outer layer as compared to the inner layer is called as the extra widening. It is also called as the mechanical widening. It is also called as the psychological widening. So mathematically this mechanical extra widening is calculated by NL square divided by 2R. So where R is the radius, L is the length, and N is the numerical value. So when we are taking the numerical, in that case I will briefly discuss about the extra widening. So the last point here you can say is the psychological widening. So when as per the IRC recommendation, when you want to calculate the psychological widening, so in that case you can use this formula. The psychological widening can be given by NL square divided by 2R plus v under root 2.64 under root of r. So you can see in this PowerPoint presentation, this is the formula to calculate the total widening needed as the horizontal curve. And as per the IRC recommendation, we are using various formula for the calculations of the psychological widening. So student, you should understand what do you mean by extra widening and psychological widening. So in today's class, we are discuss about the camber, various types of side distance, what do you mean by geometric design, and what do you mean by the super elevation, how we can counterbalance the weight, what are the widening, what are the various types of widening, what do you mean by psychological widening, what do you mean by the mechanical widening. So these are various points we are discussed today, and I hope you understand this. And in next class we are going to discuss about the various types of curve. Thank you very much.